Hey folks, so we've been doing a lot of talking about how we determine a winner for an election, right? So everybody votes, and what we found is that we can count these votes in a lot of different ways. And depending on how we count the votes, it's going to change who the winner actually is, right? So we started by talking about plurality. The option with the most first choice votes is the winner. And we looked at why, that might not be entirely fair. All right, looking at our four fairness criteria. And we moved on to look at majority as the system. So if an option has more than half of the first place votes, then that option wins. And what we found with majority was that a lot of times it doesn't give us a winner. And so that's not very satisfying if we're holding elections, right? That cost lots of money, lots of time, all of that. So, we decided the majority isn't very workable, and that's okay. And, as an alternative, we started talking about a system that's called majority with elimination. So we get rid of the lowest option first, we reassign those votes, and we keep getting rid of those lowest options until an option does have a majority. That's really nice. It's a good system. It leaves us with a winner unless there's a tie, but right, those chances are so small, it's okay. And, that violates some fairness criteria as well. So, we have to make some decisions. Yesterday, we started talking about a new voting system where we really care about all of the different rankings, right? Like first choice, second choice, third choice. And we called that Borda, right? It was Borda count, and that's where we assigned points. So, a first place option gets more points than a second choice, gets more points than a third choice, and on and on and on. And we talked a little bit about the history of that as well, right? The fact that Borda, who was in, the 17th century, really got his ideas from a guy named Nicholas of Cusa, who was working, hundreds of years prior to that. But Nicholas of Cusa doesn't get the credit for it. We still call it Borda count. Anyway, working at about the same time as Borda, so in the 17th century, is another French philosopher named Condorcet, and he and Borda didn't get along. They really disagreed quite strongly with each other. So Condorcet hated Borda count. He really thought that method wasn't fair, didn't produce just results. And similarly, Borda really disagreed with Condorcet's method. And what Condorcet proposed again was taken from older work, much older work. There was a guy named Lull, last name of Lull, and he was living on an island off of what's now considered Spain, right? And he was trying to figure out a fair way to decide to kind of collect votes and decide on a winner when people were voting for the abbess of a convent. And what Lull proposed was a series of paired comparisons, right? And we've been doing some pairwise comparison, right? Where we ignore all of the other options, but we compare like A and B. And then we ignore all of the other options and we compare A and C, right? And on and on. And so Lull was really one of the first to propose this idea of these pairwise comparisons. And Condorcet took a little bit further. So he took Lull's ideas and proposed this idea of binary, right? Just two comparisons. And what Condorcet said was that in order to win an election, every time something's being compared, so like if A is being compared to B and A is being compared to C, right? Every time A is compared to one of the other options, A would have to beat that option to be a winner. If A ever loses, it can't be the winner. And then the same thing with B. We would do a comparison with B and every other option. And if B ever loses, it also can't be a winner. And we would do that with all of the different options. And if there was an option that never ever lost in those little paired comparisons, it would be the overall winner. So we're going to go through a couple of examples today to see exactly how we do Condorcet. But just know that, kind of like majority, well, exactly like majority, it often leads to a case where there is no winner. And that's not terribly satisfying. And so this method isn't used very often in determining winners of elections. But it is a really great option if we're concerned about fairness. we can talk about that once I get back. But that's just a little bit of history about the method and about Condorcet himself. So we'll go through these examples, and then you'll have some practice. We'll chat again tomorrow. So today I'm on page 122 in your workbook. And you know how we've been checking like the pairwise fairness criteria with all of the different methods where we pair things up and we check to see which would win between every pair? We're doing something like that for Condorcet and for this method. So let's take a look at our first example on page 122. Okay, so here we go. There are 40 members of the board of directors of a company, and they have to vote to elect the president of the board. 3 candidates apply for the position. So we have candidate A, candidate B, and candidate C. So we're going to pair these up, and we're going to come up with every possible pair that we can, right? So for example, we need to compare A and B. This is one thing that we need to check. We also have to compare B and C. And we have to compare A and C. All right? So we've just kind of made every possible pairing that we could. And so let's compare them, and then I'll show you kind of how we figure out who wins. So if we compare A to B, all right, let's count how many votes A would get and how many votes B would get. So these 16 people here, they like A better than B. So these 16 votes would go to A. These 14 people, they like C better than A. Sorry, let's stick with what we're doing, and we're comparing A to B, right? So they like A better than B. So right now, we just don't care about C, right? We're only comparing A and B. So these 14 people like A best, so the 14 votes also go to A. And these 10 people like B better, so B gets 10 votes. 16 plus 14 is 30, and so A would beat B. Now off to the side, I list all 3 options. If there are more than 3, I list all of our possible options. And as soon as one option loses, I cross it off because it can't be our overall winner. So A was better than B, so B cannot be our Condorcet winner. Now let's compare A to C. So let's erase kind of these marks that we've made. So now we're pretending like B doesn't exist. So we don't have to cross them off, but if it helps you figure it out, that's fine. So if we're comparing A and C, these 16 people, they like A better than C. So A would get those 16 votes. These 14 people, they like C better than A, so C gets those 14. And these 10 people, well, they like A better than C, so A gets 10 more votes. We add them up for A, we get a total of 26. C has 14, so A beats C. So C can't possibly be a winner. Now, at this point, we could stop only because we've done every possible comparison with A, and we know that B and C can't win. But, for the sake of completeness, let's just check B and C. It's not going to change anything, but it's a good habit to get into, to go through all of them, just to make sure the last option or the last couple options don't change anything. So if we're comparing B and C, let's see, these 16 people, so if A doesn't exist, these 16 people like B better. These 14 people like C better. And these 10 people like B better. So in this case, B would beat C. We've already crossed C off, so we don't have to worry about it. We've done every possible comparison, A and B, A and C, and B and C. And nobody ever beat A, so A is our winner. Now, one of the problems with Condorcet is often there is no winner. We'll get in a situation where every possible option loses at least once. See how A never loses? In every single comparison, A always wins. That means A is the winner. B loses and C loses, so they can't possibly be the winner. So let's take a look. We do have another example here. So if you flip the page onto page 123, and this time we have 4 options. It's going to make it a little bit more complicated, but I think it's worth going through just to make sure you have the hang of this. Okay, so I've moved on to page 123. And now voters are asked to choose between 4 candidates, A, B, C, and D. The results are down here. So we have to come up with every possible pairing. So let's look at every possible pairing for A first. We have to compare A to B. We have to compare A to C. We have to compare A to D. Now we have to compare B with everything. The good news is we've already compared A and B, right? A versus B, the same thing as B versus A. So we don't have to do that, but we haven't yet compared B and C or B and D. And now let's see, we need to compare C to everything. Well, we've already compared C to A, and we've already compared C to B. So the only thing left to do is compare C to D. And now if we double check that D's been compared to everything, well, D's been compared to A, B, and C. So we've done every possible comparison. And now we have to calculate them, right? So we'll do this one first. And let's start there. Let's compare A and B. If we're only comparing A and B, these 70 people, A is better than B. So A gets 70. These 60 people, A is better than B. So A gets 60 more votes. These 50 people, A is better than B. It doesn't matter that A is pretty far down the list. As long as A is better than B, A gets those 50 votes. And these 45 people, they like B better than A. So we don't even have to add up 60 plus 70 plus 50 to know that A wins. If you want to, you sure can. All right, that's going to be 180. And 180 better than 45. So if we list every option, A, B, C, and D, well, we know that B can't be our overall winner now because B lost to A. Right? A won this contest just between A and B. So B can't be our overall winner. We're doing a whole bunch of little contests to find out the overall winner. Let's do another comparison. We did this first, A versus B. So now let's look at A versus C. These 70 people, they like A better than C. These 60 people, they also like A better than C. These 50 people, they like C better. And these 45 people, they like C better. So this, if we add up 70 and 60, we get 130. 50 and 45 is 95. So A also beats C. So C can't be our overall winner. For A to be our overall winner, it would need to beat D as well. So let's check. So these 70 people, they like A better than D. These 60 people like D better than A. These 50 people like D better than A. And these 45 people like D better than A. So this is 155. D gets 155 votes, and A gets 70. So D wins, A loses, which means A can't be our overall winner. Now, at this point, we might think that D is our overall winner, but we still have to check to see if D would beat B and if D would beat C. Just because it's the last one on our list doesn't mean it's a winner necessarily. So we've done A versus D. We can skip B and C, the B versus C, because we know neither of them can be a winner. If one of them still had the potential, if one of them was still on this list over here as an opportunity, we would have to do it. But since we've crossed both of them out already, we can skip it. But see how if we compare B and D, D is still on our list? We need to do it. Now, if you're ever unsure whether you need to do a comparison or not, it never hurts to do it. So if you couldn't quite sort out why we don't need to do B versus C, do it anyway, right? It won't hurt. It won't mess up your results to do an extra comparison. Just takes a little bit more time. And Condorcet can be a little bit time consuming. So if we're comparing B and D, these 70 people like B better than D. These 60 people like D better than B. These 50 people like D better. And these 45 people like B better. And in this case, B is going to beat D, which means D loses. So D can also not be a winner. We've crossed every option out, so we don't even have to compare C and D. There is no winner. We've crossed every option out on this list up here. So just like for majority, sometimes we have no winner. For Condorcet, we will often have no winner. That's one of the problems with this method, is that we get no winner so often. When I'm back, we'll talk more about that, and we'll talk about the fairness principles as well. But for the rest of class today, what I'd like you to work on are the practice questions on page 124. And that is it. There are 2 practice questions on page 124. So think about all the different comparisons you need to do, and then see if any option is left standing at the end. After you finish page 124, there is an assignment that'll be handed out. So let's get that done as well.